folks, welcome back to another video. Today we're looking at question 408, valid word abbreviations. The way we'll be solving the problem is by having two pointers, one for word, the other one for the abbreviated word, and then we'll keep comparing them. Anytime we see numbers in the abbreviation, we'll convert that to actual digits and jump the pointer that's in word all the way, and if the digits are the same, and then we continue the cycle. If not, we return false. It's a relatively simple problem. It's just very verbose in Java. Let's get started. Let's get the length first. Int w would be the length of the word. Int a would be equal to abbreviation dot length, right? One of the base cases here that we have to handle is that if a is greater than w, that means we know that there's something wrong because it always has to be shorter than the word. We would return false as is. If that's not the case, we have to iterate through. Let's create the pointers. Int I equals 0, j equals 0. So while I is less than w and j is less than a, we'll keep continuing. So first we'll extract the characters. The character and let's just call it w char. It would be equal to w dot character at I, and character a char is equal to a dot character at j. Okay, so if the first thing we need to check is that if both of them are letters and they don't really match, we know it's we need to return false. So if character, and we have this built-in method called character dot is digit or letter. If it is letter, a char, right, then we need to do something. If it is not, we need to do something as well, right? So in this case, what we need to check is if since one of them, if the letter in HR a is a letter, if a char is not equal, w char is not equal to a char, that means that something is wrong, and then you return false. If it is not, so the else will cover all of the other conditions, because I think the restriction is lowercase digits and letters, so the else should cover the other case in this case. So what do? We have to actually calculate the number. So int current number would be equal to, we take HR and we subtract 0 from it to get the actual digit value. And the first thing that we need to check for is if current number is equal to 0. That is a leading 0, so we would return false right then and there. If not, you need to go through a while loop, and you need to check for the next digit. So if the next digit, if the next character is a digit, we need to keep continuing. So if j plus 1, actually we need to check if it is, the j plus 1 is actually a valid index or not. So if it is less than a, and character is digit, abbr dot character at j plus 1. If this is a digit, we need to update a current number. The current number would be equal to, you take the previous number and you multiply it by 10, and then the digit that you get from here, it would be in the ones place, but you need to make sure you get the actual digit. That's the reason why you're subtracting the ASCII value from it. And then once that is done, you increment j by 1. Once this while loop is done, you need to basically move the I pointer all the way to a current number, but just one before that, because it's already taking one character into consideration when you're at I, so you skip those many characters. And once that is done, since you're in both of the cases, since you need to iterate through the next character, you would increment 1 and increment I and increment j. So that should actually take care of the entire logic that's required for the problem. In the end, you just need to check if both I has reached W and J has reached A. If these two conditions are true, that means we have reached the end of both of the strings, and the word can be abbreviated using the ABR string that's given to us. Awesome, let's try compiling this. Oh, where is that? Wait, let's try that again. OD referenced. Okay, let's see. Oh, right, sorry. So this should have been word and this should have been ABBR. Let's try that again. Okay, so the first few test cases are okay. Everything else is okay as well. Awesome. So let's talk about the space and the time complexity of the entire solution. The time complexity of the entire solution is of n, since we are iterating through every single character in word and ABBR. And the space complexity is of 1, since we're not really using any additional space, we're just using constant space to solve the problem. Awesome. So that's how you approach question 408. If you have any questions, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I'd really appreciate that. Keeps me motivated to make more videos. Thanks so much, and I'll see you